This is the last network we're going to discuss in the 104. Um, so what you're going to look to is administer network traffic. So it's going to look like, okay, hey, how do you administer network traffic? So last 2 weeks we talked about VNets, subnets, talk about what it's about. Last week we talked about internet connectivity. So hey, how do you connect a particular site to another site? So how do you connect? How do you merge? If you want to connect, if you want to connect, I'm sorry, if you want to connect your head office to branches, how do you connect it? We talked about VNet pairing and all that. Today we're going to talk about something more different. We're going to talk about network connectivity, administrative network. And now we're going to talk about things more like in the sense of, okay, I have two services. How do I load balance across these services? So we're going to look at load balancers, what they mean. This is going to sound a bit tricky to what we did in 8900, just to give you a feedback. So it's going to be like, because in 8900, we talked a bit about this, where we talked about the OSI model. So this is going to sound a little bit about that, but it's going to be a little bit deeper, and it's going to be a short one, to be honest. So we'll have time for questions. So what I would prefer to do is for people to basically give me feedback of what they think so far, where they want us to improve, if it's possible. If there's anything more you would like us to add, because I think after this we have more 5 more weeks to the end. So we have 5 more weeks to the end. All right. If I'm not mistaken. Yeah, this is module 6. So we're going to have 5 more weeks to the end. So to the end of AZ104. So tell us your expectations so far. Yeah. Let me start. All right. Administer network. What are we going to look at? We're going to look at introduction to Azure Load Balancer. So we're going to look at the different types of Azure Load Balancer. We're going to look at Application Gateway. We're going to look at Network Watcher. What is actually Network Watcher? Then the lab is about implementing traffic management. Moving forward, Azure Load Balancer. Things to note about this. So again, this forms just 15 to 20% of your questions. So the whole idea about your load balancer is that all about, hey, you need to choose the load balancer that fits your development, your environment, your deployment. So for example, now, if I have two VMs, which kind of load balancer will I need to choose? If I need to do route between two different places, I have resources in Azure, I have resources on premise, how do I route them? Which kind of load balancer do I need to route? If I'm doing layer 7 load balancing, which load balancer should I route, should I choose? So going more into this is just basically, like I was mentioning, this is choose the load balancer solution. So the load balancer you choose will depend, the load balancer you choose will depend on what you need of your application, the need of what you need. If you're going to do DNS-based routing or path-based routing, you're likely to go to application gateway or front door. So you ask me, okay, when should I choose front door and when should I choose application gateway? If my service is going to be globally available, so for example, now I'm building a banking application, I'm building a bank app, right? I'm building a bank app in Nigeria, but I know that this bank app will be accessed by my customers if my customers, for example, now I've not been to Nigeria more than a year now. I'm still using my bank app UB. How am I able to do that how am I able to do that with how am I able to do that? Because the application is probably using some kind of layer 7 load balancer globally available. That's your front door. So if you need something that is globally available, you go with front door. But if you need something that is regional, you might likely go to application gateway. So these are all the these are all the load balancer solution that Microsoft have. Application gateway is very, very good. So most times when you see Kubernetes, when you see you need to do path-based routing. So for example, I mean my path-based routing, you want /image to go to a particular endpoint. You want a particular URL to go to a particular endpoint. You can go with application gateway if it's regional. If you want it to be global, then you go with front door. Then if it's and okay, another thing to take notice is the protocols. See, look at application gateway. It uses what protocols are HTTP, HTTPS, and HTTP2, right? Same with front door. They all operate at layer 7, layer 7 of the OSI model. Load balancer, on the other hand, that is the one you call about operates at TCP and UDP. That's the one you do IP-based routing. So that's why I can say, hey, if I want to route a endpoint A to endpoint B, that's basically how we use TCP. Traffic manager, on the other hand, is used to route across different services. Sorry, guys, 1 minute. Sorry for interaction. I had a little one wants to join our training. So, whether you are using front door or you're using application gateway depends on the need of the application. So I was talking about load balance. I said load balance is really operate at layer 3. So that means IP-based routing, IP-based. So if you want to do resources between two resources, for example, now I have a VM in a VM, two VMs. For example, now let me give you an example now. Black Friday is coming, right? In the olden days, what used to happen is that hey, people would Black Friday, you start buying more servers, setting up more servers, and you now use load balance it. What you're trying to do is a traffic hit in case if this VM goes down and that VM will be able to handle this traffic. That VM will be able to handle traffic. And that VM will be able to handle traffic. So the traditional load balancer available in Azure only operates with TCP and UDP. You cannot do HTTP or HTTPS based routing. That's what I would like to pinpoint there. Traffic manager is global. It's under global resource. That means it's similar to front door, but it can route both HTTP, HTTPS. It can route both TCP and UDP. And the beauty of traffic manager, it does DNS-based routing. So the beauty about traffic manager is even if you are to show that environment you can run it. If you go to the second to the last step, the environment you can run traffic manager, you can run traffic manager across multiple environments. You can run it, for example, if I have a service that in Azure or AWS. So for example, recently Azure and AWS have been messing up, right? Let's say I have a global application now that I'm really careful about. What I might have to do is to have an instance in GCP, have an instance in AWS, have an instance in Azure, and use a tool like a traffic manager to be managing the traffic. But just to put it like that, if Azure is having issues, that means your traffic manager might get affected. Maybe you go for a different tool like maybe you use another CDN tool to manage it. But that's just what it is. So with traffic manager, you can manage. It doesn't matter what the endpoints are. Endpoints. It doesn't matter where the services are, where the servers are, whether they're in Azure, whether they're on prem, whether they're in GCP. You can manage them. You can route them peacefully. For load balancer, it has to be Azure only. For load balancer, it has to be Azure only. That's for load balancer. For front door doesn't care. Front door they say, hey, if it's Azure, if it's non-Azure cloud, if it's on-premise, same thing with application gateway. So you can route to different endpoints. It doesn't matter. In terms of security, for application gateway, you can only do WAF. What is WAF? WAF stands for Web Application Firewall. It's another form of firewall that is meant for web application. Someone asked me, so please explain the difference between the normal firewall and web application firewall. Let me explain. A web application firewall is basically for it's against web attack. My guy Dominic will tell you much about it because he's a security guy, right? It's against web attacks. For example, now there's a way so a developer will write an application, or write a web application. Now the web application, if you're assessing it, it's from the way the application is behaving, you can do SQL injection to it. That means it can do and a developer might also be using let me use for example, it might be using things, it might be using packages that are exposed that has vulnerability. With WAF, you are protected because what WAF is doing, WAF is basically designed to protect you against web-based attacks. Whereas the traditional firewall is meant for other form of attack, other form of TCP, DDoS attack. WAF is basically designed for web applications only, right? So for application gateway, you can use WAF. For front door, you can use WAF and network security group. That's NSG, right? You guys remember NSG. For load balancer, you can use NSG. For traffic manager, there is no security available to it because basically what it does is DNS-based routing. Because it doesn't care where the endpoint is. Basically, DNS, but hey, are you saying you need this or I'm going to forward it to that endpoint? Okay. If it's coming from this side, go to this side. That's just what the traffic manager does. So another thing I would like to point again, load balancer. Load balancer is the traditional load balancer. This one it's of two types. That's what's called the private and the public one. What makes it private and public? Very simple. The difference between the two is just that the one has a private IP address, the other one doesn't have a private IP address. So for example, now if I should let me put, for example, I don't know whether it makes sense to draw this in Paint. Let me bring up my paints. Just okay. So I'm putting my paint here. Let's say, for example, private. If I have application, let me call this application AZ104 app. right? This application, the front end of this application is going to be accessed by all of us. I think we have people from Nigeria, we have people from Netherlands, we have people from New Zealand, right? You can come here and just say, okay, hey, because of the different applications, I'm going to come here and say, okay, there is the front end. This is the front end, right? The front end will now be a public load balancer, right? Because of what we are associating with different IP addresses, right? I'm trying to teach you guys small architecture here. Public load balancer, public load balancer. So it will now come here and have different endpoints. The different endpoints will be what? Let me say VM1. I'm going to use VM1, VM2, VM3. What this guy is doing, this guy say, hey, he's going to distribute traffic. So if imagine suddenly we have like 2,000 people, 4,000 people trying to access this application. So if he comes, he's going to direct traffic. Oh, VM1 is already attending to Win. Okay, VM2 should now attend to John. So it will distribute traffic just to make sure that it's seamless. Some of us are old enough that road jam, when if jam come out the first 1 week, you have to, if you just see a result, you have to go by 12 a.m. That's basically what we're trying to, what the load balancers should be doing, right? Try to avoid it. So you now come, okay, what about the database of this application? How do I handle it? I can come like say, hey, this database, trying to draw it, sorry for my drawing, will now be a private load balancer, which will basically be a private IP address, private load balancer that's pointing to database. Sorry guys, I didn't anticipate that. Should I make more space? Right, that's just what it is. The difference between these two is that this one has a public IP address because it needs to be public facing, so that people all around the world can access it. But this one internally, nobody, you don't need to access the database. It's the VM that is giving you the database. The VM that needs to access the database. So the VM will basically have the database will have a private IP address, basically pointing to a private load balancer. That's just the difference between public and private load balancer. It all depends on the whether it has the endpoint is a public IP address or a private IP address. That's it. So call it internal load balancer. That's basically it. I just explained it again. So load balancer SKUs. Again, most things like most resources in Azure, but that's molecular, depending on what you want, right? If you go for standard, you have more features. If you go for this thing, if you go for premium, you have more features. That's just the way to summarize it. That's just the way to summarize it. Okay.
So just a quick understanding for some people who is still trying to find out, reiterate. Let me reiterate what he has said. Basically, to understand what load balancer is like, load balancer simply means distributing incoming traffic, network traffic across multiple servers so that no single servers gets overloaded. What does this mean? This helps you to like help your application to be fast and available at any point in time. And also he also talked about there are two main types in Azure. One is the Azure load balancer and the other one is Azure application gateway, right? So one of them operates in layer 4, which is the Azure load balancer, and the other one operates in layer 7, which is the Azure application gateway. Notice that they both work with HTTP and HTTPS, and they use their the IP address port like TCP and UDP. Understand this. These are the basics you need to understand. And again, you need to understand the OSI model. There are several layers within the OSI model of networking. So if you understand that, it will give you a better understanding of what we are talking about. Load balancer, Azure load balancer being in layer 4 and Azure application gateway being in layer 7. I mean, if you understand those two basic things, so does your application uses HTTPS or HTTP? Which means one is using port 8080 and one is using port 80. So which means whether you can consider whether you are using your application is using layer 7 or no, they are using load balancer, which is layer 4. So is your application, so the question again is talking about is your application using public internet, is your application a public facing internet services, yes or no? Which means if it's yes, which means your public load balancer or application gateway is working within that part. And if it's no, which means that you use internal load balancer for private network. So I think these are the two basic understandings. So know these two, that layer 4 load balancer is simple, fast, and work for any protocol. And layer 7 is which is the application gateway, is smart, secure for web applications. So that's just it, basically. Thank you.
Okay. It looks like someone is spending. Is anybody pending? So nobody's letting me in. Can't see anybody pending. All right. So sorry, Dominic, somebody's responding on the WhatsApp group that he's not being let, he or she's not being let in. Can you check?
No. Okay, nobody is pending here. I can.
Okay, just maybe send them the new link. Maybe they are using the old link. Maybe I'm just guessing. Okay. All right. On to the next one. Creating load balance rules. What are load balance rules? Basically, hey, how do my front end talk to my back end? That's simple. All right. If you want to, basically what you're saying, okay, front end is where the connection will come from. That's just way to see it. Back end is basically where the connection is going to land. I can say, okay, for example, now, if the front end is accepting port 443, a particular IP address, I want it to land on port 8080 on backend service. That's just what it's all about. I show you guys an example of this during this quick lab, just to show you. So you can configure. You can decide. Okay, I want my front end. I want my back end to be this. I want my back end. I want my back end. I want my back end to land to the particular port. That's just what it's all about. You can also do nothing. Nothing. Basically, say, hey, okay, I want services coming from a public IP address to land to a private IP address of my endpoint. It's all possible. It's all possible. I think someone is leaving. Okay. All right. Moving forward. I'm going to show you guys this one in the lab session. Let me just go to application gateway. What's application gateway? Application gateway is layer 7. So most times, if for example now, I'll give you an example what we use in my environment now where I'm working, where we use application gateway to do. So we built an application, right? This application is a small application that we use to for KYC. For that KYC, we want to store our images in storage account, right? The application is running on Kubernetes. So what do we want to do? We want a situation whereby if Helen wants to do his KYC, does his KYC finish? After she does his KYC, she uploads the image of that. It's not stored it's stored in storage account. It's not stored in AKS. How are we going to do that? Basically, use that load balancer. So we use load balancer. We use application gateway. Application gateway will basically set up their routes. You basically routing, say anything / images you go to this. You can say anything / for example, now with application gateway, you can also do location-based routing. Same, I can say, hey, if you're coming from Nigeria, having to try to visit some websites that you're visiting it, immediately notice that you're from this particular country, takes you that country page. For example, takes you that country page. That's basically that's basically application gateway. What's happening in the end? It's only like application gateway. From to use NGINX to do this, application gateway can now actually handle that. So how is it configured, right? The application gateway has an HTTP or HTTP listener. Then there is a rule. That rule basically saying, okay, it's telling me what to do. Are you doing path-based routing? Are you doing session-based routing? What are you doing of those routing? So based on what you configure on the rule, it will now land to the endpoint. It's actually pretty simple, right? But it can be complex. Well, what makes it complex? It can have certificate issues. For example, you can do SSL termination on application gateway in the sense that say, okay, your back end, what do I mean by SSL termination? I can say, okay, my back end does not have certificate, but I want a solution whereby if my website doesn't have it, I want to, sorry, it's any question? Someone say something.
No.
Okay, continue. Okay, I want to solution whereby, okay, if you visit https://nonso.com, all right, I install the certificate on application gateway, but when it terminates on application gateway, I want you to transcribe that and forward to the particular backend. You can all configure it in application gateway. Application gateway is very robust. It's actually it's a global resource. It's a regional resource. Sorry to because it's a regional resource, but it's actually what most people do. It can be used as an English controller in terms of Kubernetes. It's actually a very, very robust application, a robust load balancer. And it's basically, so whenever you hear layer 7 load balancing, whenever you hear web-based layer 7 load balancing, think of application gateway, think of Azure front door. This is an example of path-based routing and multi-site routing in application gateway. Think of the path-based routing, right? So.com, think of it as so.com or helen.com or john.com is sitting application gateway with WAF. I want to visit / images, just like I've been saying, hey, it's going to the image pool. If you want to visit a video, it's going to the video pool. These are basically two different locations are being configured here. Depending on multi-site routing, CK application gateway, I want to connect to vertical sites. Hey, I'm hitting the same application gateway, but if it's consultor.com, okay, Helen, and Winner has the question. just 1 second. If you are visiting contoso.com, automatically to direct you to contoso.pool. If you are visiting fabricam.com, it will direct you to this. So based on the URL you are visiting. So if, for example, that you can visit noso.com and helen.com will have the same backend IP address on the web. But once you hit it, where it directs you depends on the URL you type, DNS you type on the browser. That's basically it. Helen, winner, sorry, go ahead with your question.
Okay, yeah, I want to ask, in your previous slide, if you want to set the rule, how do you do it? Do you need to write a set of codes for it, or there is a standard process to do it?
Okay. You've written about it. You don't need to. So there are multiple ways to do it. You can do it through the portal. Through the portal, you can just select, okay, I want this port to map to this port, right? So that's the basic way to do it. That's the one you should worry about now. The next level to do it, because hey, okay, I've become an expert in doing it to the portal. I want to document this code such a way that if my user, if another person wants to see what I did, can look at that code and do it again. So that's where you don't talk about infrastructure as a code, right? But we're not doing that now. So we're just doing, so you can do it, either do it through code or can do it through the Azure portal. That's just the best way to put it now.
Okay, thank you.
Yeah, welcome. All right. I'm going to show you guys, okay, this one again. Network watcher. What is network watcher? This guy is very simple. So sometimes one of the issues we have in Azure is troubleshooting. One of the things you actually headache you encounter in Azure is troubleshooting. So I mean troubleshooting, I mean when something goes wrong, right? Something suddenly, let me say for example now, an application you hosted in Azure is not going. What is happening? What is wrong? You don't know. But you tried everything, you don't know. How do you troubleshoot? How do you know whether it's network? How do you know whether somebody misconfigured the NSB? How do you know whether it's because the application gateway is wrongly configured? How do you know whether it's a wrong route? How do you know all these things? One of the best ways to do it is use your network troubleshooting tools, and there's a lot of it in Network Watcher. So with Network Watcher, you can do it has a few features that you can use. For example, the IP flow. IP flow verify, something I've done. I've used this one. It's like TraceSat. So if you know TraceSat, for example, let me show you what TraceSat does. TMD. I'm going trace route. Let me see. Is it trace route? Trace ERT. 1 second. I'm about to show you guys. I want to show you guys what. Let me see. Okay, so let me give you guys an example. If I come here and do clear, or CLS, sorry. If I do trace that ERT, if I do, let me use, for example, let me use one of my home labs. One of my home labs have, or let me use google.com. I should be blocked, right? So, but let me show you. Use google.com.ng. Let me show you what's happening. So it's going to, what this guy is going to show is going to go in different endpoints. It's basically say, hey, this is google.com. So this guy, which IP address is this? This is the IP address, my router. This is my router IP address. He's hitting a different IP address. So this is chell.nl, this my B and IISP. So you see what it's telling me? This guy is basically telling me I'm successful to get to this place. I was able to get to your router. I was able to get to this network provider. I was able to get to this. I was able to get this. This is actually success. Where it terminates, that's where you run into issues. So, for example, imagine now you are trying to troubleshoot. In Azure, you don't even have command prompt. You don't have availability. You don't have a VM. You won't be able to run this. So, how do you run all this? How do you troubleshoot all this? Is with things like IP flow verify under your network watcher. You'll be able to trace what's happening. Another thing it has is VPN troubleshooting. So you connected VPN, you connected VPN between your on-premise and Azure, right? You're currently on-premise in Azure, but some things are not working. You want to know, okay, is it coming from Azure? Is it coming from on-premise? How do I troubleshoot this? You can use the VPN troubleshooting tool. You can use the NSG diagnostics. I've seen this thing. You remember when we did NSG? We say, hey, if you configure your NSG to have a higher, you went to configure your NSG to have to have what they call it again. Your energy is the priority is higher. For example, I went and configured allow or deny at 100 and allow at 1,000. Despite the fact that 1,000 being the higher number, deny is going to apply first. Deny is going to apply first. So you can use this tool to diagnose or try to figure out what exactly is wrong. That's just what it's all about. So for example, this is an example of the IP flow verify. Say, okay, hey, my local IP, I'm going to connect to a VM. I'm doing test. I'm getting access denied. Why is it denied? It's a security rule. That's because what an IP. That's because what this is because something there's an energy that is blocking this. So you can do packet capture. Packet capture is a situation whereby your network team is telling you, your network team, hey, is your firewall that is blocking it? And say, no, it's the Azure. You can do packet capture and use a tool like Wireshark to analyze those logs. That's also possible. Next up, diagnostics is like your trace starts, basically trying to figure out, okay, where am I being blocked on this? That's what next up is allowed. You can either use it to visualize the network topology. So you want to know, okay, I want to know how things are connected in my Azure environment. I want to know my NIC, my NSGs for a particular VM, for a particular application. I want to know how they're all connected together. You can use the visualize network topology to basically come up with a diagram of your connections. This is also very good, but sometimes you don't know that you have NSG you applied on the VM level and another NSG you applied on the subnet level. With this diagram, you'll be able to see how the connectivity is all about, how they're all linked together. Okay, that's the end of the this thing. I want to do a quick lab to just do a small load balancer. Let's see. Let me see, Azure. Sorry, I'm bringing it to the screen so you can see. Well, so far, any questions, guys? Any questions? Anything you'd like me to touch light more? Okay, no questions. Is it even making sense? That's the general question now. Is it making sense? Everybody's so quiet. So I want to know, is it making sense or?
We are trying to assimilate.
Okay, trying to assimilate. Okay. How do I start? Okay, let me do a small load balancer. Let me use a small load balancer, app service. So I'm going to create two app service. App service servers, create a web app. I'm going to create a web app. So this guy just let me call it web app one. App one, right? Create a new one. Web app one. So I'm going to use John Winner. Is he available? Yeah, he's available. Okay. All right. I'm going to do FIFO code container. Let me use container. Let me see. Maybe Linux with container. And this way I can just kind of central no West US. So I'm using West US. And I'm going to use please give me the cheapest one, please. B1. I want to do B1. Yeah, John Winner at this will be the URL. I want to guide and next database, and I don't want a database container. You just use the quick start container nginx. I'm going to use it in the port 80. So that's where it's listening to port 80. Available to the public, yes. Unit integration, no. To monitor and secure, I'm not doing any of this. I'm just moving forward. I want to create two web app and a basically load balancer. Basic load balancer. Let me see whether monitor and secure. I don't want to monitor and secure. Please, can you be fast? Thank you, my friend. Enable application insights. Okay. I know we're still going to do app service, so I'm going to leave this one for now so I will not confuse you guys. Review and create. All right, I'm creating one now, right? John Winner. I'm going to create another one. As this one is creating, I'm going to create another app service. Web app. I'm going to create another app service. I'll call this one web app 2. I'm going to use who am I going to use now? I'm going to we'll start with use John. I'm going to use Helen and Vincent. Okay, so Helen Vincent. All right, I'm going to go for container again. Okay, what are you trying to show me? I know you're deploying now. Just don't mess with my deployment. Let me open. Okay, let me just put in a new tab. Okay. All right, app service, creating a new one. I'm going to come and do create a new resource group, create new web app 2. Okay, I'm going to call it Vincent and Helen. All right, Vincent and Helen. Container, same thing, but I'm just going to use it. I'm going to put this one in East US, right? The other one was in West US, remember? So I'm going to go for something cheap, please. Let me just go to review and create. I don't want the database, just go ahead straight. Okay. All right. Creating now. I'm creating this. Can go to this resource now, right? John Winner. Let me see. So let's browse this application that we visit now, right? This application, we browse it now. Click on the DNS URL is what let's see. It's loading. Let's see. John Winner, blah 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 dot West US. Wow, nice code. Okay, you can see here HTTPS is loading. Let me see. This one is still deploying. Let me see. It should give us something first. I'm waiting for it to come up. Just a few more minutes. Now, what network am I in? Okay. The right network. Shifting this more. Go to resource. Also trying to open the Vincent and Helen. Let's see. Which one of them opens first? It's taking a while. Is it because I went too cheap on the underlying server? Maybe that's the issue. Well, let me see. Okay. All right. Welcome to NGNX, blah, blah, blah. Oh, I should have used a different image, right? So that we'll know the particular one we are heading to. That might be ideal, but let's see. Okay, this is still loading. This is off, right? So what's the load balancer? Imagine that this guy is the same application. Let's going to do a TCP-based load balancer now, for example. So if it's a TCP-based load balancer now, what we need to do is just come here. Let me show you guys. Load balancer. Load balancers, right? If you click on load balancers, load balancer is I can click the application gateway. I can create a normal load balancer. I'm just going to create application normal load balancer, standard load balancer. All right. So what is it asking me to do? I'm going to create it in a new resource group. LB, just call it LB. Right? I'm going to call it load balancer load. You call it load, right? It doesn't really matter. So you can standard, yeah. It's not going to be it's going to be public. I can make it tier regional, which is basically the route across the regional, but let me make it global. The regional load balancer can only be deployed in your home region. Make sure you are selected the valid region. Yeah. Let me use this one, for example. Front-end IP address. Yes, please. I need it to have a public IP address so that people can access it. So I can say yes, go ahead and create new Azure redundant available routing available anywhere on the internet. I'll call it LB IP. All right, public IP address. That's what I'm creating. What is the okay? Yeah, LB. I'll call it LB. LB. I'm choosing IP version 4. Save. Is there. Next thing is going to ask me backend pools. Backend pools are basically where do I want the load balance to enter? Right. If you hit this, where should the traffic go? So in this case, I'm going to point to my two my two app services I just created, right? So I'm going to call them as backend pools. So name backend pool one. No, I don't want virtual network. Backend pool one, right? Save, right? Okay. So inbound rule. Let me just review. Next inbound rules. Inbound rules are basically saying, okay, which rule do I want to apply? I can come and say, okay, I want it to direct to this one. I want it to direct to that one. So, but I don't want to do this here. I want to do it when I finish create. Let me create it. I'll go and configure it. Let me just review and create. If I can review and create, what I want to do is to show you guys how to configure the rules in the end. All right, let me create it so I can go to the load balancer and configure the rule. All right, going to the resource now. Going to the resource. If I come to, this is the load balancer, right, that we created, then go to settings, backend pools, right? This is the pool one. If I click on it, this is pool one, virtual network. I don't have any virtual network cancel. I need to attach the probes. So let me see. Oh, sorry. All probes, front end connection is there, backend pools. Hold on. I'm missing something, I'm pretty sure. Delete this guy. Yes, delete. Let me see. If I should add a pool web servers, virtual network save. Let me see. Web servers. So if I come here, let me see. There should be an option. I'm missing something, guys. Hopefully, I will be able to find it here. If I click inside here, okay. Drop down shows virtual network in the same subscription. Yeah. Yeah. I'm missing something. And I know what I'm missing because I didn't have. What I'm trying to do. I'm trying to make the endpoints to be. Try to make the endpoints to be app services instead of them to be VMs. So I don't have any VNet deployed, so that's why it's doing like this. So sorry, scratch that. Let me take it back. Take it back. I'm going to create VMs inside this. Let me see. Create a VM. I want to do less configuration. That's why I was trying to. Oh yeah, just go ahead and create this. This is fine. Create Ubuntu. Yeah, web app. Just call it VM1. Yeah. I don't want to worry about all this. Just go ahead and do it. Password because I want to. Azure user. Trying to create a VM now. Yeah. Allow pause. It's a page. This. I'm going to allow all of this. Going to this networking. Yeah, public IP. Of course, you need to create new public IP address. Yes, please.
So it's like having two VMs. One is public, one is private.
No, I want to have two public IP addresses. Just so I'll be able to connect. So it's not going to route through that. It's just for me so that I'll be able to connect. That's what I'm trying to do. Delete. Yeah, delete when the VM is deleted. I need to create a VNet. Virtual network. Yes. ETOS. Yes, please. I think that should be good. Yeah, Azure load balancer. Load balancer, not Azure load balancer. I think, yeah. Allow this. Select load balancer. Yes. Attaching to this load balancer, attaching to this endpoint. Yes, please. Next. Let's see. Yeah. So the security reasons I shouldn't be doing this. What I mean, I shouldn't be doing. I shouldn't be exposing my ports, my ports over the internet, right? SSH port and 80. I shouldn't be also over the internet. But of course, this is lab for lab purposes. So I'm just doing this. So please, your environment, don't do it like me. Yeah, environment, don't do like this. Careful with it, right? Just to put it lightly. Let me see where my which one is this? Web app 2. Okay. I need to put it in web app 1. So web app 1 needs to have its own VM. So creating its own VM now. Close and create. Yeah, I'm calling it VM1 or VM2 now. I created VM2. Yeah, I don't want to worry about this because I'm deleting it in the next 5-10 minutes. Azure user, and I'm going to do things around allow ports. I'm going to enable all of this also. Going to no, I need to do the networking path. Yeah, go with 172. I don't care. Allowed ports. This delete this. Attach to the load balancer also. Yeah, attached to this load balancer. Oh, it wants it to be in the same virtual network resource. Okay, let me put it in the same virtual network. Let's see. Okay. Yes. So all of them are in the same virtual network. I'm going to review and create. Let me see. All right, I'm going to go ahead and create it. Okay, so I want to do some config in this VM. Let me see whether I'll be able to do it. I want to do some SSH config inside this VM. What do I want to do? I want to install Nginx in this VM, and I want to install let me see SSH Azure user this. Yes. Let me see. apt get nginx. Let's see. apt install. I always forget this command. apt install nginx. Is that it? Okay. It wants me to do it as roots as sudo. No, sudo -i.
Yes.
Yeah. nginx. So what am I doing? I'm trying to install a web server. So we'll be able to browse this over the URL. That's what I'm trying to do. Yes. So I'm actually trying to do more than that I should be doing. What I'm trying to do, I want to have Nginx running on one and HTTPD running on the other one. So that way we can do some form of, we can test our load balancing rule, right? That's what I'm trying to do. So the second one is running, so this guy is installing now. So if I do crawl localhost, now let me see. No, crawl localhost. Yeah, it's running. So I think it's running on HTTP. Let me see. 18. Okay, it's running on HTTP. So this shows that the browser is running. So it means that if I go to this now, this will not work. Oh God, no. Now VM2 was first set up, right? So if I go to the public IP address of VM1 was first set up, right? So let me see. If I copy this this now and go to HTTP column, the URL, right? So this is our VM now. This is public IP address of VM. This is what it's giving me, right? Guys, can you see? Right. So time to work on VM2. So I want to connect to VM2 now. Yeah, let me connect to VM2. SSH Azure user at public IP address of the VM. Yeah, so time to enter the password. Okay, if I do sudo I then can do apt install httpd. So I'm trying to install Apache on there. Okay, it's not called httpd, it's called Apache 2. So switch to Apache 2. Yes. Going. All right, so we've installed VM2. If you clear the screen, clear, sorry, and do crawl, and do crawl localhost. You can see it's telling us this is the different, it tells us the browser is open. So this is it. So if you copy this URL, this is nginx, this server 1, this server 2. And if I do HTTP, right, the page for this thing. So you can see nginx is different to the Apache, right? Now let's configure our load balancer, right? Go back to load balancers, load balancers. Click on this, click on load. I named it load, which is a very funny name. Taking this guy off now. So going to our backend pools. See, we have a front end now, right? This is our front end and this is our backend, right? So it means that whenever you hit this, I want to see the rules in this guy is configured with. Is it configured? Which rule is it configured with? Just basically added it to. Okay, let me see. Help groups, load balancing rules. Win. So this is what your question is about. So you can add a rule. I can say, okay, hey, which rule do I want? It rule name. I'll say HTTPS, right? Front IP address this, backend IP web servers, ports. I'll say, okay, when it hits on port 443, the backend port should be about 80. All right. That's basically what I'm doing here. Session persistence. So session persistence say, hey, imagine if I am coming, I want to always be going to the same server. So imagine, so do you want to be always going to the server, or do you want to be going to a different server? Right. That's one of the things you can configure. That's one of the things you can configure. Or do you want to direct to a different server? So imagine I'm trying to do just like I'm registering a form in your website. You want to check by if your browser fails, you refresh. If it hangs, you refresh your browser. Do you want to direct to a new server and start afresh, or do you want to be consistent in where you're going to? So I'm going to just leave this as none now. And ideal timeouts. How long do you want to time out? You want to be able to do TCP reset. These are the kind of rules you can configure. But I'm just going to leave everything that's basic. Existing probes. Let me create a health probe. Let me support 80, blah blah blah. Test. I'm just going to leave this as test. Just saving it now. Not saving. I'm trying to save it now. Okay. So it's saved now. So the way to test this is to go to the public front end of this front end IP address. This is our front end IP address. Assuming I do the writing, right? What should happen is when I go to this. Oh, sorry, shouldn't go there. Okay, that means not, I didn't do the topic well, but it should direct me. It should direct into any of the services, but it's not doing that. Let me look at my config again. What did I miss? Rules count 1. Let me see. Okay. Yeah, gateway. No, it's not gateway load balancer. 80 so 80 to 80. Let me just make it 80 to 80. Save. So instead of HTTPS, I'll do HTTP. See what's happening now. It's taking me to this. Let me refresh the game. I'll put it on the chart. Let me see whether it will direct somebody to a different URL. Maybe if you put it, you can take it to a okay, someone asked a question. Boyega said, what's the difference between Azure user and a root user? Okay. A root user has more permission than an Azure user. Azure user is like a normal user. So for example, the Azure user can be known. So it can be Boyega, right? It can be anything. But root user is the root admin. Especially in Linux, anytime you take root is the highest level of permission you can have. Please, can somebody go to this HTTP? Tell me whether you can see NGINX or whether you can see which one are you getting?
NGINX.
NGINX. So it's not directing you. Okay. See, I just tried it in a different browser now, and it took me to this is it. I tried it in a different browser. It took me to HTTP. So just look at this now. They are the same applications running on two different servers. That's what a load balancer does. So much traffic is in one, is directing traffic to the other one, right? So if I refresh it again, it might take me to NGINX. See, just take me to NGINX. Let me refresh this. See, you see what is happening? It's just load balancing. That is load balancing 101. So it's all about rules. Again, you saw the mistake I made. All right, I was expecting the traffic come from port 3 should hit port 40, but I didn't have a certificate configured. That's why I started failing. So I have to reconfigure it and make it 80 to 80, right? So, but you can do port mapping and this mapping. Okay.
So a simple context here. Let me just add up a simple context here. Is like, for example, when you say you want to go to, we have like 20 people trying to connect to google.com at the same time. You know, Google don't usually have just one server for people to route into those their website. They have multiple servers where people can route it. So what the load balancer does, it look for the server that is less busy and direct that traffic to that less busy site to be able to access, so that it will be easy for people to access. Imagine 10,000 people coming to access google.com at the same point in time. What a load balancer does is it looks for the one that is the server that is less busy, that there's no traffic. It will direct you to that traffic, and then the site will be open for you to be able to access freely. That's why you see that if you try to understand, you see that over 10,000 or 10 million people access Google every blessed day. So why is Google fast, right? Because of these are the things load balancer does. It looks for the traffic, the one that is less busy, and direct the traffic to that place so that you're able to access it simple, easy, fast, and reliable, so that it will be always available for you. Sometimes you understand why people are filling a form in Google. There are over 2 billion people filling form on Google every blessed day, or in a week, if I'm not mistaken, right? So what the load balancer does is it looks for the server that is less busy. It directs the traffic to that site, to that server, and then it will be able to access. You find out that you're accessing it, I'm accessing it. You are filling the form, I'm filling the form, right? You are trying to understand why is this fast. So this is an example is just demonstrated right now. I don't know if that makes sense to you guys. Thank you.
Hi guys. Any questions? Any more questions? Anything else? All right. Okay, I think that's where we'll stop for today. I still have my questions packed. I know you guys think you have escaped. You have not yet escaped, right? I still have the packed. So I just had a crazy week, and so but I promise before this class finishes, right? before this class finishes, I'm going to make our time and do that lab for us again. So hopefully it will be fun. Steven, you joined late. All right. Thank you, everyone. See you next week.
So sorry, I joined late. I was on the call. So sorry about that.
No problem.
But
I think
I was able to catch
watch
up
the recording.
with some. All right, it's fine. I will watch the record and I will. Thank you so much.
Yeah, you're welcome. All right. Thank you, everyone.
Yeah, thanks, guys. Bye.
Yeah, have a lovely week. Yeah, bye.
Yeah, thank you. Bye.
Bye.
Bye.